Hello everyone. So today we're gonna continue from last video, sprint is a problem, and today's goal is to verify our result using Monte Carlo simulation. So let's first review what is the problem. The problem is that given a triangle, given a right triangle, if you put a dot inside this right triangle uniformly, what is the average sum of the distance the dot to the three sides. So in that case, in this graph here, there will be an expected value of x plus expected value of x plus y plus h. So we calculated the result in last video, which is 47, and today we're gonna verify this result using using Monte Carlo simulation. And I'll be using C++ for the job today here. So the first thing is I want to set up a good random number generator, which is I'm using GNU GSL library. And the function for verifying the result is in this average sum of distance function, which takes an argument of repeats, which is the number of samples we want to generate. And in here, we're going to have a sum, and then after we calculate all the sample sums, we're going to divide it by the total number of samples. So what we do is that we're going to accept or reject the proposed sample for x and y based on the condition that this dot is in this triangle, which is that we see that so the first thing we generate a proposal, we generate x and y, which is x is uniform from 0 to 45, y is uniform from 0 to 60, and then the condition for x and y is that y must be generated on this line, so it cannot go above the slope here. So y must be less than or equal to 60 minus 4 times x divided by 3. We see that from the last video. So if it is greater than that value, then we'll continue, we'll reject that sample, we're going to propose a new one until we find a new one, a satisfying sample. And we're going to and then we'll calculate the h, which is, we also talked about that in the last video, the formula for h. And then we'll sum up all the samples, x plus y plus h, for each sample, and then we're gonna divide it by the total sample size. And by doing that, this value, the return value from this function, should be very close to 47. So let's run that and see what we got. So now if we run this function, we get as 47.007, which is sample size of 1 to so 10 to the power 7, a pretty large number. And so that's our simulation, and that verifies the result. I hope you like it. Bye everyone.